Hello, further to my previous video covering the installation of the soil and waste systems in a new house. In this video I'm going to briefly show some of the first fixed pipework installation on a large new house. As you can probably see from the images, there is a lot of pipework in a house of this size. On this installation I have chosen to use traditional, if you like, copper tube and fittings. I've chosen to use copper tube on this particular installation as I think this will give me the best results. Regarding the volumes of water required for both the central heating and hot and cold water supplies. I'm not opposed to the use of plastic pipe and fittings, but for this particular installation I just don't have the space to accommodate the plastic pipe and fittings. In fact, if I was using PEX pipe, I would probably have to put in double the amount of pipe work to achieve the same result. Here I'm just showing how the volume of water travelling through the pipe work would be greatly reduced if I was using plastic pipe and fittings. It's important with low temperature heating that you have plenty of volume going to the radiators, so the plastic pipe carries less volume, so I would probably have to double the size of the pipe or double the amount of pipe, so therefore that's why I've gone for copper pipe. I possibly could have combined the copper with the PEX push fit type pipe work and fittings, but for maintenance reasons I would prefer not to mix the two. The reason there is not a lot of space under these floors to accommodate a lot of pipework is because of the amount of steel that's involved in the construction of the property, which this is making it a bit of a challenge with the pipe runs, etc. As you can see, this property is being constructed using mainly, on the first floor particularly, engineered joists, which lend themselves quite nicely to getting lengths of copper tube threaded in between, without the need for too many joints. Here I'm just showing how I'm soldering the fittings. In actual fact. No need for a burn barrier, as I'm not going anywhere near the timber with the blow lamp, and I'm always very careful not to scorch anything, and I have got burn barrier just in case. But with this type of construction there's plenty of space and it's quite easy to solder up pipework without actually setting fire to anything. If you're not familiar with soldering up pipework, basically you can see me here brushing on the flux, and the pipe is reasonably clean, so there's no need to clean the pipe, as this is an active flux that I'm using, i.e. it cleans the pipework and prevents the oxidisation as it heats up. So I apply the heat equally to the pipe and fittings, trying to get the heat all around the pipe and fitting. Not too much heat because I don't want to burn the flux and blacken the pipe. Once I consider there is a reasonable amount of heat applied, I just add the solder and watch it run around the joint. I don't mind if a little bit of the excess solder drips off, as this is a good indication that enough heat has been applied to the fitting and pipe. The molten solder is obviously drawn right into the socket of the fitting by capillary attraction. Once the pipe and fitting has cooled down a little bit, I try to give it a wipe over with a damp cloth to remove any excess flux that might have been left on the pipe and also might have dripped on a pipe below or adjacent to. So where possible, it's always advisable to try and pull a bend rather than use a fitting. So in this instance it's a little bit awkward to get full pull bends in, but I try to do as many bends pulled on the bender as I possibly can. If there's a need for me to identify a particular pipe, I will mark it with either blue or red tape indicating hot or cold or flow or return. And this is always best to do because it's so easy to get confused or to lose concentration. And you can always use the tape as a reference when you're just checking it after you've installed all of the pipework. It is so easy to make a mistake, and I always bear in mind that we are all fallible. What I'm fitting here are the 22mm supplies to one of the bathrooms. Now 22mm is more than adequate, as the bath shower mixer in actual fact only takes 15mm, and obviously there's a basin and a WC. I will be doing all the reducing down of the pipework up in the actual bathroom itself. All of the bathrooms and shower rooms will have their own dedicated hot and cold water supply. These supplies will be from a centrally located cupboard on the landing of the property. There will be a main hot and cold supply into the cupboard, and from there it will branch off hot and cold to all the respective bathrooms. There will also be a secondary return from the cupboard back to the cylinder. Ordinarily, each individual bathroom supply, hot and cold supply, would return to the plant room. But in this instance, as I explained, there's very little space to get all the pipework back to the plant room from each individual bathroom. Working overhead in this way is quite a time-consuming job, but believe it or not, because it's such a big house, it does make it easier to get all the pipework in the respective places. Just here you can see that the cold pipe is actually resting on the hot pipe, but they'll be separated once I put the insulation on the pipework. When making up a soldered fitting, always make sure there's plenty of heat supplied to the pipe and fittings. The number one reason soldered fittings fail is because there wasn't enough heat applied, and therefore the solder didn't run all the way around the fitting. So here you can see all or some of the pipe runs. There's quite a lot of pipe in this house, as you can imagine, and it's just spread everywhere. And the reason that it's taken some strange routes is because we've got these steels that are in the construction of the property, and we can't get under them or over them, so we have to go around them in some way, shape or form, and this is the route that I've taken. Fortunately, it's worked out quite well. This is the centrally located cupboard on the landing of the property that I referred to earlier. As you can see, I've got all the hot and cold supply pipes all in position, ready to be connected up at the second fix stage. Also in this cupboard is where all the hot supply pipes will link up to the secondary return. If you're not familiar with what a secondary return is, it's just a return pipe back to the hot supply on the cylinder, which basically you have a loop of hot water travelling around it. It's pumped, and it eliminates the dead leg when you open a hot tap. The dead leg is basically the amount of cold water that you run through a hot tap before you actually start receiving hot water through the tap. Here now I'm working on the second floor of the property, putting in the pipe work for the third floor, and as you can see it's conventional type joists, so I'm just showing you here how I drill the joists ready to feed the pipe through. Obviously it has to be done quite accurately, as all the holes have got to line up, because you've got to put straight lengths of pipe through, so you don't want any kinks and you don't want any restriction in the pipe. You don't want to have to bend the pipe to get it through a particular hole. You don't want it coming in contact too much with the timber. Pipe work, obviously when it gets hot and cold, expands and contracts. So therefore you want it to travel through a hole as easy as possible without pinching or touching the sides. This is why for instance a 15mm pipe I'll drill a 22mm hole. This allows for plenty of movement in the pipe, and reduces the amount of noise that might occur if the pipe was pinched through a very tight hole. Once I've got all the pipe work to the locations of the various bathrooms, I've got to then, before I can test it all, I like to put in anything that's going to be concealed within boxings or behind walls. So here you can see I'm starting to make up a shower control. This is a concealed shower control. That means that all of the pipe work and everything is hidden within the thickness of the wall. So what I'm doing here is I'm just making up the fittings prior to cutting the hole and burying it in the wall. I'm applying PTFE tape to the male iron threads that will ultimately screw into the shower control, and I like to go around a couple of times and have a bit of a build up on the shoulder of the actual fitting. There are 4 fittings to be wound into this shower control, so I make them all up here on the bench before going over to where the shower control is ultimately going to be fitted. Once I've wound them in hand tight, I finish them off with a spanner. Make sure they're snugged down really tight. Here you can see I've chased out the wall and run some of the pipe work in and fitted the shower control where it's ultimately got to go. When the control is fitted, it's crucial that you get it level and upright, because once it's buried in the wall, you've got no margin for error. Here's the completed installation of the shower control with 2 outlets, high and low level. This is a view of one of the other bathrooms, and as you can see here, everything's been fitted that can be plasterboarded over, if you like, tacked over. And in this instance the shower control is within the thickness of a studwork wall, which simplifies the job no end. Once I've first fixed each individual bathroom, I then pressure test all the pipework. I do this by pumping the water in via my pressure pump here that you can see me pumping, until it reaches about 5 to 6 bar. I then leave it, and I just leave it all under pressure. Leaving it under pressure will expose any leaks. It is also a good protection against other trade damage. If any other trades damage or puncture a pipe, the water will come out at pressure and expose the damage so that it can be repaired before it can go any further. It's my experience that problems normally occur due to other trade damage. This is why we take a lot of precautions to prevent accidents happening. For instance, here's the precaution I take to prevent damage happening to any pipework sticking up through floors. And here's an example of precisely why I need to fit those blocks to the pipework. The other trades have been up here, done some sort of alteration, just thrown stuff everywhere. So once I've tested all the bathrooms individually, there's all the other service pipework to test, i.e. the heating, the towel rails and the mains hot and cold to the centrally located cupboard. So what I'm going to do here, I'm going to join them all together, which will save me a bit of time, and just put one big pressure test on them. What you can see here is all the pipework that's coming into the plant room, if you like, and the cylinder will be in this area. The heat pump will be on the other side of this wall on the left that you can see, and all of the associated fittings and controls will all be in this area. The underfloor heating manifold will be to the right at the lower level. So what I'm going to do is temporarily connect all of these pipes together so that I can get a pressure test on them. I wonder if at this point, if you haven't already subscribed, if you would consider doing so. It helps give incentive to create more content. Thank you. When I've joined all the pipework together, I then connect it to the main via a hose pipe. I let the main run until it's under full pressure, and in this case it's 6 bar, the pressure in this area. Once I can hear it stopped filling, I disconnect the temporary hose and I put my pressure gauge on it just to double check that I've got adequate pressure for testing. So that's a steady pressure, and now I'll just go around and check the pipework for any problems that might occur, probably none, and I'll just leave it. When the pipework has been under pressure for a couple of days, it's time to insulate all the pipework. Apart from doing the obvious, the insulation will reduce any noise that's generated within the pipework, and it also insulates any cold pipework from getting warm. As you can see here, there is also additional rock wool insulation within the thickness of the floor for sound and obviously insulation. So that's it for the first fix of the pipework on the first and second floors. And I just thought I'd show you the progress of the work on the outside. While we've been working inside, there's obviously been work being done on the outside, and this is the completed roof, and it's rather a big roof as well. Well, it's almost completed. This dormer's got to be finished, but that's just a matter of time. This is an image of the lower elevations of the property. It's going to be K-rendered the top half of the house, which will make it look quite attractive. So this is what we're awaiting at the moment. The scaffolders all been adapted and ready for the plasterer, and obviously a little bit of roof work. Hopefully my next video will be shorter, and I'll be showing you the lengths I have to go to install the extractor ducting for the various bathrooms and the kitchen. If you have watched this video to this point, I thank you. And if you haven't already subscribed, I wonder if you would consider subscribing. It is free and it helps give incentive to create more content. And I thank you for your subscription.